All right, so big time thank you to my coworker to the rescue. I have been able to figure out how to get this topology to work the way I intended it to because of the clues that my coworker gave me. The clue being that if you have a ebgp connection, I'll read off what he said here. So he said, you need to add BGP Multihop. It only uses a TTL of 1 for ebgp, but typically you would just use whatever physical interface is directly connected for ebgp. So a TCP SYN message for ebgp has a TTL, time to live value of 1 by default. So even though we have this static route and it's set up to go, we know that, so we saw that we were only getting our IBGP connection to come up, but our ebgp connection, that had a TTL of 1, so it could not come up until we added the keyword multihop to increase that TTL value and allow it to form that connection. But now we've got all of our BGP sessions up, so that's a really good thing. I will be sure to include that in the summary of this video, that we learned more about multihop and the default TTL values in BGP connections, how in ebgp it's going to be set to 1. In IBGP, I guess I'm not sure. I will look it up. Here we go. This looks like it'll be good. So configure the maximum time to live TTL value for the TTL in the IP header of BGP packets. For BGP multi-hop scenarios in which ebgp peers are not directly connected to each other, setting a TTL is optional. The default setting is 64. This is interesting. For BGP single hop scenarios in which ebgp peers are directly connected to each other, you can optionally set the TTL to 255 and configure an inbound, what? Well, let's look up the next hop, the multi-hop. Aha, here we go. So it's related to this. So configure an ebgp multi-hop session. So, okay. Yeah, unfortunately, not much information here either. Maybe in the example it will explain more. So, here we go. Understanding ebgp multi-hop. BGP is an exterior gateway protocol, EGP, that is used to exchange routing information among routers in different autonomous system, ASs. The following are 2 ways of establishing ebgp multi-hop between routers. When external ebgp peers are not directly connected to each other, they must cross one or more non-BGP routers to reach each other. Configuring multi-hop ebgp enables the peers to pass through the other routers to form neighbor relationships and exchange update messages. This type of configuration is typically used when a Juniper Networks routing device needs to run ebgp with a third-party router that does not allow direct connection of 2 ebgp peers. ebgp multi-hop enables a neighbor connection between 2 ebgp peers that do not have a direct connection. The default behavior for an ebgp connection is to peer over a single physical hop using the physical interface address of the peer. In some cases, it is advantageous to alter this default one-hop physical peering ebgp behavior. In such case, one such case is when multiple physical links connect two routers that are to be eBGP peers. In this case, if one of the point-to-point links fails, reachability on the alternate link still exists. Okay, so that's satisfying for me. Just the default behavior of eBGP only allows for one hop because that's the paradigm that there is for setting up eBGP. You would just do it for the physical interface. But there are some situations, like if you have redundant physical interfaces, where it makes sense to set up a multi-hop connection. So this might not necessarily be one of those situations, but we're here to learn about the loops. So let's move on to that. But this, I think, was a really good lesson in the default behavior of BGP and how sometimes you are required to add knobs to get it to work. Okay, and one thing we forgot to do, or I forgot to do rather, is go ahead and export these routes into BGP. So I'm not sure where they want these exported. Here we go. In the first example, an eBGP route is first advertised by router 1. So it's going to be an eBGP route, so we're obviously going to advertise it this way and not that way. So let's do that. So edit policy options, policy statement, advertise, set from route filter, and that 2.3.4/32. Exact. Set then accept. Set then reject. Oops. Okay, so it's got to be done into edit term 1, and we'll do this. Okay, so that looks about good to go. We do need to, I think, actually have the routes. So let's set it up as a static route. And then we won't need a next hop. We can have it be install, and then we can just have it say discard. So it's going to show up into the value, but it's going to, yeah. Okay, and then of course we need to okay, so I have been doing some incline push-ups lately, and I didn't know that 3 push-ups could destroy your elbow so bad that you can barely even move it. But I guess 3 incline push-ups can do that for some people. One of those people being me. So I guess I'm just never gonna. I gotta put my NBA, NFL dreams on the sideline and keep working on this test, unfortunately. All right, so let's see here. Let's see here. So, perfect. So we got to set that export, that advertise policy as an export policy. So set export advertise. Okay, so now hopefully well, we've got to set it up for the other routes as well. In the first example, the eBGP route is first advertised by R1. The first AS in the AS path is that, configured on R1. The second AS in the path is that, configured on R2. AS is sent at trans number. Okay. Show route command shows not okay. Well, let's export the other one as well. In the second example, an eBGP route is advertised first as R4, and this is an eBGP route. So let's see that there was an update message first sent out with that included in it. Oh, this is nice. Maybe we can just start Wireshark and it will have the capture still going. Ah, perfect. So, but I don't know if the capture is still going. Now it looks like it's not. Classic GNS bug. All right, but hopefully this will fix it. All right, so now we've got our TCP keep alive. So let's roll back that config and then reapply it, and hopefully we'll get updates. Of course, we're going to get some updates now because we rolled it back. But we got our 4-way disconnect, hopefully. Actually, we might not get it until, oh yeah, and we didn't, yeah, here's the update message. All we did was withdrew routes. So we'll see, yes, that is a withdrawn route. So let's add it back in. There we go, there's our update message. So sure enough, we are adding that in. I'd like to point out the TTL value. Just to kind of take note of that because that has been important. So it's going to be here. So we got 64. Okay, so here we've got our path attributes. We've got our network layer reachability information. So sure enough, it is being advertised into BGP. So in the first example, an eBGP route 1.2.3.4 is first advertised by router 1, as we can see in the Wireshark capture. The first autonomous system in the path is AS1, 2. So yep, sure enough. The second AS in the path, oh, we don't have a second AS in the path. So let's see if it's, so one thing that's interesting is it looks like it's alerting about 10.255.14.172. So I don't know where that came from. It looks like it's only talking about this address here. So I don't know why they're interested in this one or what that even is, because clearly that was not the route. So I think that's worth a download because it's just, this is really confusing here. So so what is do you mean 1.2.3.4 or 4.3.2.1? Oops. Okay, so yeah, I'm not sure what that is. I don't see that anywhere in the topology. So let's try to find that route though. We might need another export policy for it on router 2 to make sure it goes to router 3. So let's do a show BGP summary on router 3. And looks like this neighbor is going to be going to router 3 actually. So I don't know why they want to look at router 4. I mean, I don't know why they want to look at router 4 if the route is meant to go through ebgp this way. I don't see the value in looking at 1.4 if you're trying to get information about route 1.2.3.4. Oh, okay. I see what they are thinking. So this is advertising protocol, not receive protocol. So they want to see the routes go here, and then go out there. So in order for it to do that, I think we're going to need export policies on all of the appropriate routers. Okay, and not to get too far off topic, but when I talked earlier about doing incline push-ups, made my elbow hurt, I was not talking about anything where my feet are up. I was talking about basically just having my feet against my arms against a wall and going like, yeah, that hurts. So just to make that clear, that is something I feel the need to do for some reason. All right, so router 2 and router 3 are going to require these export policies in order for that route to be shown in the show route advertising protocol BGP output on router 3. So let's just see advertising protocol BGP, and then it's going to go to 192.168.1.3, I believe. Yeah, and of course it's not going to be advertising anything. That's because I don't have an export policy. But I do have the route because it was exported there, so I can certainly do, yep, so it's a BGP route, so I can certainly just use a route filter because it'll just look for that route no matter how it's there, if it's a static route, if it's a direct route, or if it's a BGP route, as it is in this case. And you can see, yep, it's got the path, so we're going to be loading that up with a lot more ASs. Okay, so now we're going to get, oops, a bunch of garbage there, but let's do show route advertising protocol BGP 192.168.1.3. Oh, that's interesting. I don't understand why. Oh, maybe the group isn't. Let's hear show configuration. Pipe display set, pipe no more. So I'm exporting it back to the neighbor I received it from. Yeah, I guess I'm not sure what's going on because I've got the route filter. Is it a /32? Yeah, it's a /32. Why? I guess I don't understand why this route filter isn't being applied on the that network there. Let's take a look at the help menu for this. List of routes to match. So yeah, we want that route to match. So I think it'll just look in the routing table for it. I mean, it's right there. So should match that. I don't know why it's not. Let's be more specific with where this is meant to be exported. It's meant to be exported to one specific neighbor, not to all of the neighbors. And I think it's going to go to 3. I will double check. Yes, it's going to 3. Oh, yeah, my elbow's like messed up so bad. It's probably my posture is just not the same, and my body's kind of getting used to new circumstances. Huh, yeah, this is really interesting. I'm not sure. Oh, you know what? It's not advertising it because I don't have the next hop self configured. It doesn't have a valid next hop, I think. So once I do that, I think it'll show up. So configure private, set or edit policy options, policy statement. Next, hop self, set term 1 from protocol BGP, set term 1, set term 1, then next. There it is, next hop self. Perfect. And then I can do a set term 2, then reject, just to, because I think the default is accept all. Or actually, this is where I can choose whether or not, oh, I gotta do it then, but this is where I can choose whether I want it to be discarded silently or whether I want an active rejection message. So I don't see the option to discard, which I'm kind of surprised that's not in there. But let's just do a reject just for completeness sake. So this is going to be another export policy that will apply, but we'll apply it to all of the neighbors. So edit protocols BGP, show pipe display set relative, edit group. We'll apply it at the group level. ebgp set export next hop self. Okay, so hopefully this is going to be it. We'll now see that those routes are advertised. Oh, and yep, we don't see that. So yeah, I guess I'm not. Oh, so here we go. So for some reason, it went back into active state. So that's the reason why it's not advertising that route. Oh, oh, it looks like we've got some extra junk on there too. All right, so hopefully that can go into established. I guess I'm not sure why it's no longer going to an established. It was there before, so it must be that that export statement. So of course, what I can do, which will be kind of the easiest way, is just remove those calls. So I'm still going to have these defined on the box, but they're not going to do anything because they're not being called anywhere. And I'll start with this one and see if the BGP neighborship comes up. So it's still inactive. I know it takes a while sometimes, but I doubt it was that one. I think it was the other one was the more likely culprit. So let's look at that one. Okay, so there's still an issue here. Let's show system rollback compare, see if I made any changes on here. So I added multi-hop on there. What did I do before that? I added the local address. So I wonder what the issue is now. Let's try pinging that. Okay, so we use the source address as well. So yeah, it looks good. I'm not sure what the issue is. And it just randomly stopped working. I mean, it was working before, but now it's not working for some reason. Even though it was working before we had these policies on there. Yeah, and just to make sure I'm not completely wrong about that, I will scroll up here because I'm pretty sure I started the video by doing a show BGP summary on every device. Yeah. So yeah, that's how I started the video. I did a show BGP summary on every device. Oh, it looks like this one just made it into connect. It didn't make it all the way to established. I think I need to increase the multi-hop value because it's going to be, I'm not sure what I need to do. And I might have to just put this by the wayside because the purpose of this was to learn about 4-byte ASNs. And I think I've done that. You know, I'm now on to different topics. I'm learning about ebgp Multihop. I'm learning about, I am learning about routing policy. But I might need to be aware of the time. I guess I'll put in another 20 minutes to this, but then the after work video, unfortunately, I think I'm gonna have to move on. I kind of hate to give up on things and move forward without seeing them through to completion, but I have a test. It was coming up in 127 days, I think yesterday or even more days ago than that. So if I continue at the current pace I had been, it would mean 4 hours a day of study, which I don't have time for, so I will need to pick up my pace. All right, so shoot. I would like to get this this going here. Yeah, I just can't believe that. So let's see here. This is connection 2 to 3. Yeah, so .3 from .9. So let's do a trace route on this actually and see just how many hops we're gonna need. So we'll need just one hop. Let's see if increasing that multi-hop value helps. So let's give it a TTL of like 64. So it is inactive. Let's take a look at the Wireshark Capture on that link. Oh, I think I got to stop capturing on a link before I start on another one. There we go. All right, so I'm not getting any traffic over that, even though it is active. So that I mean, that doesn't seem like it's the truth, because if it's active, it's going to be sending those TCP SYN messages. So I don't really believe that there is no traffic. I wonder if there's an issue with the sniffer. Aha, there we go. So now I've got a bunch of traffic. So it was just late in showing me the traffic that's on there. Oh, and it looks like I got a BGP handshake, but then I got a notification message, and then I got a disconnect. So it looks like it actually was setting up a BGP connection. It's just there's an issue that we're going to see here in this notification message. Bad peer AS. Perfect. So this is coming from .9. So .9 is going to be itself router 2. So when it sends it to when router 3. So this is initiated on router 3 because we made even numbers passive. So router 3 initiates it. Router 3 sends the first open message. It says, I want to form here's my AS. I want to hook up with your AS, which is going to be, let's see here. What is the AS? Does it not say? Looks like it doesn't say what the other AS is. That's too bad. But yeah, it looks like it just gives its own AS. It doesn't say what's the AS it wants to hook up with is. Okay, but let's kind of keep this in mind. So this is router 3, which is an odd number, so it's not passive. It's communicating with router 2, which is passive. But router 2 receives that open message and it says, oh, okay, well, here's my AS 6500. But your AS is a bad peer AS. I can't hook up to yours because you have a bad AS. But why does it have a bad AS? So let's give this a Google. Open message. So BGP Open Message bad peer AS. And let's go to the RFC. Here we go. So bad peer AS. If the autonomous system field of the open message is unacceptable, then the error code must be sent. So why the termination? Oh, God damn it, it's outside the scope of this protocol. So I mean, that's what I want to know is the determination of acceptable autonomous system numbers. So I guess I'll just Google for that. Okay, so here's the ASN table. So we're going to see what kind of numbers we're using, and maybe that'll give us some insight into why it is unacceptable. So the peer AS, so this is .9, which is right here. Where is it? It's yeah, it's up here. So this is router 2 saying that the peer AS of 60,000 is an unacceptable AS. So let's try to figure out why that might be unacceptable. So 60, aha, here we go. So 65,000. Oh, no, it's 60,000. So that falls into this range here. So it's a public ASN. I don't understand why it would be unacceptable. No, I do know. Because our local ASN is 65,000. And look at what range this falls into. Private use. And then we're trying to hook up to 60,000. Look at what range that falls into. Public use. So, you know, what kind of a protocol would allow there to be use between something that is private and something that is public? You know, something that is entirely public. You can't allow it to communicate with something that's private and you know, have it be private. That's the point of it being private. So very clearly the issue here is that we're using both public and private ASN. So we need to either use two public or we need to use two private. And this is, I think, we're definitely worth a downvote because I mean, that's a big issue. I'm really glad I learned about that though. It's really gonna help with the test, but I think they need feedback for that because so on router 2, the local AS is 65,000. Is private, so 65,000, that's going to be private, is private ASN 65,000, but on router 3, the AS is public ASN 60,000. Using trying to connect a public and private ASN will result in a bad peer AS notification message. And will prevent a BGP neighborship from going into established. All right, so that was actually a pretty good lesson. Hopefully they'll take a look at that because I was about to give up on that. I just wasn't getting anywhere, but good learning lesson. This is something I definitely wanted to kind of have a better understanding of anyway. So the fact that they're both in reserved ranges, but they're not in the same reserve ranges, and the scope of the intent behind the reserve ranges that they fall into are not compatible across their ranges. So that's definitely our issue. So let's kind of think about which one we want. Do we want to go with the public or do we want to go with the private? Let's go with so the rest of them, let's see what the rest of them are. So this is 1 billion. Yeah. Oh no, sorry. This is 1 million. So let's see what 1 million is. It's gonna fall into here. So this is in the reserved range. Let's see what 12596 is. 12596. So that this is public. So yeah, let's go with public. Just like the other ASN for IBGP is public. So yeah, let's go with public. So we're gonna go with instead of 60,000, we'll go with 65,001 on router 3, which is oops, sorry, that's private. So instead of 65,000, we'll go with 60,001 on router 2 because that's a public IP. Oh, and it looks like I got about 5 minutes left, but I think that's going to be plenty of time. So let's get this going here. And I think I will put more time into this. This has actually been pretty invaluable. I've learned a lot of things. I had to get help from a coworker, and I had to learn more about autonomous system numbers. So I'm learning a lot of things, and I'm seeing a lot of things that I might see on the exam. So I want to, as long as I'm doing that, I want to keep going with that. So I think I will devote another video to this. It'll be the after work video, but that I think will be the maximum amount of time I can afford to spend. Hopefully the Wireshark Capture is still going. So let's get a fresh capture. Yeah, so we already got our notification message. We should see some coming. I think it's the same thing where it's delayed. It's not showing us in real time the traffic that we're receiving. So, aha, and you can see what the problem is. I forgot to change the PAS on this side. Kind of thought there was something I was missing on this side. All right, yeah, if you're configuring bidirectional communication, only configuring one side is not, I think, the best strategy. But as we did see in the community strings example, you can affect other routers just by configuring one router and not that router itself. That was kind of interesting. Okay, but unfortunately, it's still down. Yeah, and we're not even seeing the capture. So let's see here. Local AS 6001. Oh, I'm missing a 0. Okay, and I've got the 0 on this side. So now hopefully this reign of terror will come to a close. Still nothing. Let's count those zeros again. So local AS 6. Oh, now it looks like I've got an extra 0. Oh, okay. So this is interesting. Oh, okay. So it wasn't that I had too few zeros. It was that I had too many zeros here. So yeah. So let's go and remove a 0. Hopefully we can finish that within the next few minutes so that I don't have to cut the video short. Okay, finally the village is saved. Yep, village is saved. So hopefully there's a BGP connection now. Yes, so perfect. It's been established now. Oh my God, that was a nightmare, but the nightmare has subsided. We learned more about ASNs. We learned that you can't have a public and a private try to communicate with another. We submitted multiple downvotes. One was for that, and then there's another one. I forget what it was, but yeah. So now let's see if it matches the documentation in that it is advertising that route. So show route advertising protocol BGP 192.168.1.3. Aha, perfect. So now we're advertising it. So let's go to router 3. Show BGP summary. Yep, we've got 2 established connections. Show route advertising protocol. Oops. BGP neighbor 192.168.1.2. Oh, we don't need the neighbor keyword. It's always kind of unclear which when you need a keyword like that and when you don't. So yeah, clearly now we're not going to have 65,000 anymore because we went public over private. The private is the higher numbers, and here's the chart again. So we've got 2 ranges reserved for public. Aha, here we go. So remember reading about this. So this is reserved for AS pool transition, and 0 is reserved. So our public is kind of split up by this, but we've chosen the public instead of the private, which is going to be higher. So the private will be in this range here, kind of a smaller range, and then we've got lots of public 32-bit ASNs. I'm kind of surprised they didn't go with that one. They have 2-byte ASNs, or instead of 4-byte ASNs, but they have 4-byte support. So yeah, I'm wondering if they're missing a 0 or something, because if they had an extra 0 on this, then it would be a public 32-bit ASN, and this is about, we're learning about 32-bit ASNs. That's the whole point of this thing. So I bet you that they're missing a 0 there, and to have these both be public 4-byte ASNs instead of one private 4-byte ASN, or the larger one, one private 2-byte ASN, I mean the larger one, and then one public 2-byte ASN, the smaller one here. So thanks for watching. That's gonna end the video for now. I think I will have one more video on this after work, where I go and look at loops specifically, but unfortunately I have been, I think, devoting a bit too much time to topic. I'm running out of time, so I'll have to move on to routing policy for communities tomorrow, no matter how far I get, or if I can't complete an exercise or something, I'll have to move on. But stay tuned for more videos, and thanks for watching.